All right, so we go through these equals with absolute value. Understand our graph is always going to be a V. And what I'm going to do first is I'm going to deal with my vertical stretch and shrink, horizontal stretch and shrink, based off the number in front of my absolute value. If the number in front of the absolute value, in this case at -2, if the absolute value of that number is greater than 1, we have a graph that's going to be narrow and go down or go down or go up quickly. So anytime that number in front of the absolute value is, the absolute value of that number is bigger than 1, so absolute value of -2 is 2, that represents vertical stretch and horizontal shrink. Okay. I'm going to get my vertex. What number makes the absolute value equal to 0? If x is 1, the absolute value is equal to 0, and I keep my 7 as my y coordinate. And then I'm going to, because there's no fractions here, I'm going to count down 1, I'm going to count up 1. So I'll put the 2 in. Y equals -2, absolute value of 2 minus 1 plus 7. Y equals a -2, absolute value of 1 plus 7. The absolute value of 1 is 1. So y equals a -2 plus 7, which is 5. You only have to do it once. We know our absolute value graphs are going to be symmetric. So if 0 is 5, then 2 has to be 5. So when I graph my points, 1, 7, 2, 5, and 0, 5, and it's important you draw a V. Okay? When you draw the V, it's important that you put it in straight lines. Okay? That's going to be extremely important to do. All right? And that's pretty much your graph. Now, here, my vertex, -1, -2. The number in front of my absolute value is less than 1. And if the absolute value of that number is less than 1, the absolute value of 1/2 is less than 1, we have vertical shrink, horizontal stretch. Since there's a fraction in front, I'm going to count down by 2. I'm going to count up by 2. And I'll plug the 1 in. Y equals 1/2, the absolute value of 1 plus 1. We'll meter. 1 plus 1 minus 2. Y equals 1/2, the absolute value of 2 minus 2. Y equals 1/2 times 2 minus 2. 1/2 times 2 is 1, minus 2 is a -1. -1 on both sides. Look at the -3 and the 1. 1, -1. -3, -1, and my vertex right here, -1, -2. And you can see it in the graph as well. This is narrower and goes down quicker. Vertical stretch, horizontal shrink. Here the graph opens up wider, but not nearly as quickly. So therefore that represents vertical shrink, and horizontal stretch. Okay, same deal here. Okay. My vertex is going to be -2, 8. I'm sorry, not -2, 8, but -2, -8. Okay, we keep that sign out here. We change the sign in here. -2 plus 2 creates that 0. Okay? Because there's a 4 outside, vertical stretch, horizontal shrink. Okay. I'm going to go -3 and -1. Doesn't matter which one of these two you put in. I'll put the -1 in. -1 plus 2 minus 8. The absolute value of -1 plus 2 is 1. The absolute value of 1 is 1. And 4 minus 8 is a -4. And that's my y. When I plot these points, -2, -8, -3, -4, -1, -4, and now I draw my V. And it's important you draw straight lines. It's important that you draw straight lines here. It's got to be a V, because the next step of the parabola is going to look like a U. The next one, my vertex is 3, 2. Change the sign here, we keep the sign here. The 3 makes that absolute value equal to 0. And we keep the 2, and that's my vertex, 3, 2. Okay. The negative 1/3, that fraction in front, means we're going to have vertical shrink, horizontal stretch, which means a wider graph that doesn't go down or up as quickly. When I pick my points, I'm going to use 0 and 6. I'm going to go factors of 3. That way I don't deal with fractions. So y equals 1/3. We'll use 6. 6 minus 3 plus 2. The absolute value of 6 minus 3 is, we have a 3 in the absolute value, and it's y equals negative 1/3 times 3 plus 2. Negative 1 plus 2, that's 1 and 1. Okay. So 3, 2. We have 0, 1, 6, 1. Draw my line, and that's my graph. Okay, and you can notice this graph is certainly wider, but not going down nearly as quickly. This graph here is narrower, but going up quicker. Okay, so the vertical stretch goes up quick or down quick, narrow. Vertical shrink goes out wide, but takes longer to go down or go up. Okay, and when you have vertical stretch, you have horizontal shrink. When you have vertical shrink, you have horizontal stretch. You never have them both, right? One is shrink, one is always stretch. So here, my vertical shrink and stretch, same deal. The number in front of the parenthesis, absolute value is bigger than 1. So vertical stretch, horizontal shrink. The vertex, negative 2, 8. Since there's no fractions, I'm going to go negative 3 and negative 1. So y equals negative 2 times negative 1 plus 2 squared plus 8. So now I'm doing PEMDAS. Negative 1 plus 2, that's the parentheses, is 1. 1 squared is 1. You do the exponent first. And then negative 2 times 1 is negative 2. Plus 8, that gives me a 6. So these are the two numbers. 6 and 6 that go with negative 3 and negative 1. You don't have to do it twice. Negative 2, 8 is here. Negative 3, 6. Negative 1, 6. Now, if you want to give yourself a better use, see, the V is easier to draw, particularly when there's a number bigger than 1 in front of the absolute value. If you think it'd be helpful to you, pick one more number. Negative 1 to 0. 0 plus 2 is 2. 2 squared is 4. 4 times negative 2 is negative 8. And negative 8 plus 8 is 0. So 0, 0 is also a point. And therefore negative 4 is 0 is a point. This sometimes helps people with their curve. Okay, I cannot stress that enough though. When you have a parenthesis squared, your graph is a parabola. It has to be curved. The second one here, my 1/3 represents vertical shrink, horizontal stretch. My vertex is 3, 9, and I'm going to count by 3's. 0 and 6. So 1/3 times 6 minus 3 squared minus 9. 1/3, 3 squared minus 9. 3 squared is 9. Minus 9, so we end up with 3 minus 9, which is a negative 6. Oops, I'm sorry. 3 minus 9 is negative 6 here. Quick mistake that we can fix. My vertex is 3, negative 9, not 9. Okay, hopefully everyone sees that. The vertex here, the 3 makes the parenthesis here equals 0, and the negative 9 left over. All right, so my points, 3, negative 9, 0, negative 6, 6, negative 6. And if you want to plug another number in, you can plug 9 in if you want it. 9 minus 3 is 6. 6 squared is 36. 1/3 of 36 is 12. And 12 minus 9 is 3. So 9, 3 is a point, and negative 3, 3 is a point. But you can see the parabola goes out wider, but parabolas move up quicker than absolute values. That's always going to be the case. This parabola, while it's certainly wider and has horizontal stretch and vertical shrink, it does move up quicker than an absolute value would, and that's always going to be the case. So this one here, the 4 represents vertical stretch, horizontal shrink. Okay. The vertex, 1, negative 10, which means I'm going 0 and I'm going 2. If I plug a 0 in, 0 minus 1 squared minus 10, negative 1 squared minus 10, negative 1 squared is a positive 1, and 4 minus 10 is a negative 6. So that's what these points should be. 1, negative 10, 0, negative 6, 2, negative 6. If you need an extra point, plug 3 in. 3 minus 1 is 2, 2 squared is 4, 4 times 4 is 16, minus 10 is 6. So 3, 6 is right here. Three 6 is right here. So then on this side it would be negative 1, 6. And that'll help you keep a U. But that's what that graph should look like, a very skinny graph. Vertical stretch, horizontal shrink. Here, we get the negative 1/2 in front, so that's vertical shrink, horizontal stretch. Negative 2, 6. I'm counting down by 2, negative 4. I'm counting up by 2 is 0. Negative 1/2, 0 plus 2 squared plus 6. Negative 1/2, 2 squared plus 6. Negative 1/2 times 4 plus 6. And then negative 2 plus 6 is 4. Negative 2, 6. Negative 4, 4, 0, 4. If you need that extra point, put a 2 in. 2 plus 2 is 4. 4 squared is 8. Negative 1/2 of 8 is negative, 2 plus 2 is 4. 4 squared is 16. 16 times negative 1/2 is negative 8. Negative 8 plus 6 is a negative 2. If I went on this side, 1, 2. This is what my parabola should look like.